Hello. So here is all the tube data from 2021. Remembering tube data, it was the area viewable through the paper tube as a function of the distance. But our purpose in this lesson, let's pretend we don't know what this data set is for a minute. The purpose of this lesson is to explain how you can use residuals to check whether you have the right family of functions to fit your data if you don't have any contextual clues about which types of growth would be appropriate or inappropriate. So let's start by fitting a linear model to this. I mean, it doesn't really look that linear, but this will illustrate my point. So ax1 plus b. So here's our linear model. You can actually have Desmos display your residuals or do a residual plot here. So I'm going to say plot. And so these black dots are the residuals. Let's hide our original. Let's hide everything except the residuals. So one thing I'm noticing about these residuals is there's a definite pattern to them. There's sort of an upward, like parabolic or some other curvature to them. So if your residuals show a pattern like this, that's a clue that the family that you fit to your original data is probably not correct. Because if we think about what residuals represent the leftover error after you've tried to predict your y values using a model. So if there's a pattern to the errors, that must mean that there's a pattern in your original data that your model is failing to match, is failing to account for. So you don't want to see patterns in your residuals because that just means that your model is failing to pick up on a pattern in the original data. Let's look at a different family and see what the residuals for a different family look like. So we know for theoretical reasons that the correct model for this data should be quadratic. So let's fit a quadratic and see what the residuals look like. So there's our quadratic function. Let's plot the residuals. Let's hide the original data. And so here you can see that even though the magnitude of the residuals is increasing as our distances get further, they're approximately evenly distributed positively and negatively. So there isn't any real kind of curvature or pattern here that indicates that we're failing to match some pattern in the original data. Let's do another curve to see what the residuals look like. So here's an exponential family. Let's again look at the residuals. So these might look just the same as the residuals that we saw a minute ago for what we think was theoretically the correct family. Let's not do that. I think the takeaway lesson here is these things can be subtle and you won't always be able to judge. One thing I'm noticing is if you look just in this interval between like 0 and 14, almost all of the residuals between 0 and 14 are negative. And remember what a negative residual means. That means that the model is over-predicting those values. So we know that our model doesn't fit the data very well for the initial interval. And then almost all the values between 20 and 30 are positive residuals. So I am sort of detecting a bit of a pattern where you go from negative residuals through a transitionary phase up to all positive residuals. So even though it sort of looks like there's no curvature, I am sensing that there isn't an equal distribution of residuals that are both positive and negative kind of across the board here. So this one's a lot more subtle, but I do think we could have figured out that this is probably the wrong model as well. Anyway, you be sure you do the homework, this upcoming homework, because there will be a couple other problems about residuals and patterns in residuals. But I just wanted you to know that this is an actual technique that you use in statistics sometimes to determine if you have the right model for your data.